Now, what if we have two switches connected back with two wires? Okay, I'm going to pick some ports. Let's say I'll use port number 24. On the top, I'll choose port number 1 and 24. On the other side, I'll do the opposite. 24 here and down 1. Yep, so let's put numbers. Will help us to understand how the blocking port is selected. I'll call this a switch 2. And this is switch 1. For better visibility, I've zoomed it for you. Now I don't need to do any configuration. Even a host name is not necessary. The reason is all ports in the switch port or the switches are up. Ports are already up. BPDs are already running. So somehow they are ready for use. This is not the case with the router. You should be very clear with this. For routers, you have to go to the interface and say no shutdown. Basic criteria, you have to say no shutdown. And then you have to put the IP address, etc. But on the switches, you see just plug and play. Now you're already seeing the blocking port. On switch 1 F01, I see already a blocking port, which is in amber color. Let me take a snapshot. Snip. Okay. So what I'm expecting is this with the small MAC address. I did not check. You know, I just opened this router switches. The switches I just opened and I connected the cable. You are seeing me doing all this. But I can be sure that this switch has got small MAC address. How do I know that? Because I see both the ports are in a forwarding state. I told you in the previous class, on the root switch, which is the root switch? The switch with the small priority. But did I change any priority? No. The default priority is 32768. It's the default priority. Because the priorities are tied, it will definitely compare the MAC address. And this is the root switch. That is why both the ports are forwarding. It is a root switch because of the MAC address. The MAC address must be smaller. We are going to now go compare it. Compare the MAC address. I'm in switch 2. I'm going to show you two things. One, this switch is considered to be a root switch because of the MAC address smaller than the other switch's MAC address. Secondly, I also want to show you that they have same priority. For your better clarity, I would like to put the host name here. So this will avoid confusion. When I show the switch, you will know which switch I'm showing you. I'm on switch 1. Let me give a name. All right. Now, as we discussed, as I explained, switch 2 is a root switch because I see both the ports are green. And we know the priority, we did not change the default priority is 32768. So definitely the MAC address of switch B, switch 2 must be small. What is the command to see these things? Simple, show spanning tree. Just one command, show spanning tree. You can see here, this bridge, I told you, bridge and switch, they are interchangeable. The older name for switch is bridge. This switch is the root. We see that in switch 2. Let's go to switch 1 and see. Show spanning tree. This says this root switch is connected via 24 port number 24. See, 24 port number is a root port. I told you the port that connects you to the root switch is the root port. Yeah, so this is a root port, and these two are designated to forward. This is a blocking port, alternate. You see, F01 is an alternate blocking port. Look at this. Yesterday I was talking to you about the cost. The default cost for fast Ethernet is 19. Why? Because fast Ethernet means 100 meg. 100 meg, the default STP cost is 90. If you want to change this cost, you can do it. You can change it going under the interface. And also, I told you the priority. 128.1. Why? Because it's port 1. 128.24. Why 24? Because it's port 24. Now let us go to second switch and see both the ports are designated to forward. The reason is this is a root switch. And now when the priority is same 32768 on both the switches, in both the switches the priority is same 32768 plus 1 the VLAN number. You see we have only one VLAN. The VLAN number will be added to the priority. That is why it shows 32769. So the priority is same on both the switch. So the only tiebreaker must be the MAC address. I copy the MAC address from switch 1. This is the MAC address of switch 1. Let me paste it on the board so that we can relate, compare. Okay, now let's copy the MAC address of switch 2. In switch 2, if you notice, the upper deck and the below deck both have got same MAC address. The reason is, this is the MAC address of root switch, and this switch happens to be the root switch. Whereas on switch 1, the top one will be the MAC address of switch, root switch. This is the local MAC address. Right? Now only on the root switch you will see both the MAC address same. The upper MAC address always MAC address of root switch. Now when you compare the MAC address, here it is 000, here also 000. Here it is C, whereas here it is 3. What is meaning of C? In hexa, C is equal to decimal what? 12. 12. right? A is 10, B is 11, C is 12. Is 12 big or 3 big? 12 is big. Spanning tree likes small. So switch 2 is the root switch because of small MAC address. 3, that one is 12. Okay, now we understood this part now. Which part? We understood this part. The root switch, the priority, the MAC address, and why these things are forwarding. Now we are trying to understand what made switch 1 to block F01 port. We are now comfortable with switch 2, the root switch. Do you have any question on switch 2 side? Do you have any question on switch 2 side? Okay. Now what this switch will do, this will see whether going this path is cheaper or going this path is cheaper. Unfortunately, both are fast Ethernet, so the cost is a tie. Both the cost is same, 19 and 19. If that is the case, then it will compare the incoming port cost from the root switch. This is going to say port priority 128.1. This is going to say 128.24. Spanning tree likes small. You see, small is coming on this port. Small is coming. You should not see local. You should see coming. Okay. So this is receiving 128.1. Even though the local cost is 120.24, that doesn't matter. What is coming matters. So this has become the root port. And this is going as blocking alternate. Is that clear? Okay. Now let's see whether we can change the other switch as a switch with blocking port. Can we change, or I would like to ask question. You answer. I want switch 2 to have a blocking port. What is the easy way to do it? That's it. That is all you need to do. You see, MAC address you cannot change. And first thing it will check is not the MAC address, it will check the priority. So changing the priority is the best option. Now priority, why they kept it as first criteria? Only when there is tie in the priority it comes to the MAC address. Why it is priority first? Why is the priority kept as the first criteria? It is because we can have our own custom root switch. See, the MAC addresses compared to old cell phone, old laptop and new laptop. Let's say you have two Dell laptops. When you compare the MAC address of old laptop and new laptop, which MAC address will be smaller? You have two laptop. One you bought 10 years before. Another one you bought 25 years before. Both are del. Both are del. Which MAC address will be smaller? 25 years old or 10 years old? Let's see, 24 hexabit will be always there, but comparing MAC address, definitely one MAC address is going to be smaller than the other. Which one will have the small MAC address? Old one or the new one? Of course, very correct. See, when you compare these two MAC addresses, you can see 003, 00C. Like this difference, you will see in all vendor, not only in Cisco ports and Cisco switches. Always the older device will have 0003. Newer device will have 000C. Older device will have small MAC address. Older device will have small MAC address. New device will have big MAC address. Now I want to ask you next question. That olden days computer 25 years before, was it faster compared to 10 years before laptop? Definitely not. 25 years before you were having Pentium. Pentium generation 1, Pentium generation 2. Huh? No, not even 2. Pentium 1, that's all. Pentium 1. And some Celeron processors, I think. P1 processors. But today you have processors, Intel processors, with lot of advancement, very fast, generation 5, 4, Pentium 5, Pentium 4, Pentium 7, sorry, not Pentium, Intel 7. So older MAC address devices are poor in performance. The spanning tree is picking the switch with poor performance as the root switch. Not good, no? I repeat. Spanning tree elects a switch which is poor in performance. When it goes with a MAC address, the switch with the small MAC address is an old MAC address. Sorry, is an old switch. Old switches, CPU will be slower. Older switches will be definitely slow. That is why they put priority on the top. If you feel so, if you feel switch 2 is older and you want switch 1, the new switch to be the root switch. See, root switch will have more job to do than the non-root switches. Because all the ports are forwarding now, the root switch will have a lot of work to do compared to non-root switches. That is why they kept a priority on the top. You can go and change it. For example, let us consider the switch 2 as a old and we want our new switch to be the root. Old switch is now a root switch which we don't want. So I go here and I change the priority. The current priority is 32768. I'm going to change it as 0. This is how we change. Spanning tree. Priority, for VLAN 1. Priority 0. If you have many VLANs, you have to say for every VLAN. Now, you can see 0 plus 1, the VLAN number. And this has already become root switch. And soon the blocking will be turned into forwarding. Right now it is in a listening state and the other port is in a learning state, meaning what it is listening? It is listening to the topology change that has happened. How it knows the topology changes happened? The BPDU tells. The BPDU tells, hey, my priority is 0. The other switch says, my priority is 32768. Okay, then I will be the bridge. Yeah, they're in a listening state, and then they start learning the new topology, and then now they are forwarding. You see, so easy, no? We made switch 1, which is a new switch, to be a forwarding switch by changing the priorities. Now, we change the priority to 0, and the priority here is 32768. As a result, these two are forwarding. You can see at the background. Switch 1 F01 and F024 is forwarding. Now, this switch will try to find the low cost path. Unfortunately, the 19 is a type. So I just want only one answer from you, straightforward answer. In this switch, which port will be blocking? F01 will be blocking, exactly correct. It is because of the incoming is 128.24. Here the incoming is 128.1. So F01 will be blocking. Let's go and check. Yes. Let's go inside and check. Show spanning tree. This is no more root switch, and F01 is blocking as you said. You said correct. Now, do you understand this complete story, or do you want any part of the story to be repeated? No. It will take only the, yeah, correct. Default priority. For example, if I'll create VLAN 20, it will automatically add 20 to 32768. Automatic. It will. Answer is yes. Any other question? Okay. Then I'll ask question. I have a VLAN called 100. What will be the default priority? I said I have VLAN called 100. I have a VLAN called 100. What will be the default priority? 32868. Isn't it? Okay. All right. So those things, we will be discussing anyhow in CCNP in detail, all these research things. Any other question? All right. If no questions, then we are going to another topology. We are going to another topology. If you take this topology with the topology with 3 switch, this is F01 port. It's hidden here. F02. Here this is F01. The other switch, F02 here, F01 here. Now, I can already see a blocking port. Which means, compared to all these 3 switch, this switch has got the bigger MAC address. Secondly, this is not a root switch. This is not possible to be a root switch because it has got a blocking port. And I'm telling you, this is also not a root switch. how I am saying, if this is the root switch, for this switch to go to the root switch, this will be very long path, 19 plus 19, too costly. It would have gone this way and blocked this port. It didn't block this port, which means this is the root switch. See, I did not see at all, but I can still not predicting. I can be sure that this is what root switch is. And root switch, both the ports will be forwarding. Now, this switch, I'll call this as switch 0. The switch 0 and switch 2. Now, this is a root switch because of small MAC address, smallest MAC address. Now, this switch 0 and switch 2 will find low cost path. You see, this path is 19 only. But if it takes this path, it will be 38. Isn't it? 19 plus 19. Tumba jasti. So, this switch 0 will say, I will use this as the root port to talk to the root switch, root port forwarding. And this switch will also say, yeah, I am also going to use this port as a root port forwarding. The reason is cost. Now what they do, this switch and this switch has got no comparison like what you had in the earlier case. Earlier case, between two switch, you had two links back to back. So you are comparing the incoming port cost. Idhila vara cost kammiya, idhila vara cost kammiya compare pannீங்க. But there is no wipe in this. There is no possibility of comparing like that. You have only one link. Then what it is going to compare? It is going to compare their MAC address. This switch will say, my MAC address is smaller than switch 2. So I will not block. I will be called as a designated forward. Then this will say, yeah, my MAC address is biggest. So I will block. You understand? Let's go verify this. According to us, what we have learned, switch to F02 should block. Switch to F0. Oh, F01. Sorry. Okay, now you can see the number correctly. F01 is blocking. The reason is the MAC address of switch 2 is bigger. Okay, so F01, that is why F01. Okay, F01 is blocking. And this MAC address should be bigger than other two. So I copy, I paste it here. Now let us move on to the other switch. In this switch, according to what we have learned, this port is a root port, the other port is a designated forwarding. No blocking. show. First, let's give a name. Show spanning tree. You can see F01 is a root port, yes, and F02 is a designated forwarding, yes. And let me paste the MAC address. This is neither small nor large. This is medium. Now let's go to the switch. They should have the smallest MAC address among these three. I'll copy this MAC address. And you see this is the root switch. All the ports are forwarding. See, only on the root switch you will have all ports designated forwarding. In the non-root switch, you will have blocking and root port, or instead of blocking, you'll have designated forwarding and root port. There will be definitely one root port in a non-root switch, and the other port will be in either blocking or designated forwarding. Okay, now compare the MAC address. See, this is 00040 zeros. This is a 2090. So this is the smallest. Now comparing to this one and this one, if you see here you have number 2, but here you have 0. So this is the smallest. That is why there is no blocking. This is the smallest compared to this two. When you compare these two, switch 0 has got the small one. All right. This is 2. This is 0. So this is the largest MAC address. That is why it is blocking. That is why this is blocking. Did you understand? Even in this scenario, if you want to change some other switch as a root switch, you can go and change the priority. All right. Similarly, you can keep building big topologies, and then you can decide who will block. You can connect another switch here, connect this one like a box. So there will be one root switch for this, another root switch for this. This is also redundant path. But those things you can try at home, right? So we will stop